Assalamualaikum and good morning Dr. Ang and everyone. Today our group will present a research entitled The Relationship Between Autonomous Motivation and Hours Spent Training per Week of Student Athletes who are actively competing in sports. So, this study aimed to determine the level of autonomous motivation among student athletes and examine whether motivation is related to the numbers of hours type spent training each week. So, before we begin, let me introduce our group members. So, my name is Muhammad Haris Haikal bin Muhammad Atta. This is Ahmad Zaim Nazhan, Nakib Zahin, Muhammad Ashad, Arfin Haikal and Muhammad Amirul Daniel. So next slide. This is our introduction. So our introduction is motivation plays an important role in influencing athletic participants, commitment and performance in sports. This survey was conducted to assess the motivation levels of 35 participants from different sports using Sport Motivation Scales 2 (SMS2). The findings provide an overview of participants' motivational characteristics and help identify factors that encourage active involvement in sports. So next slide. So for the research question, the first point, what is the level of autonomous motivation among student athletes who are actively competing in sports? Second point is there a significant relationship between autonomous motivation and hours spent training per week among student athletes who are actively competing in sports? For the research objective, first, to determine the level of autonomous motivation among student athletes who are actively competing in sports. Second, to examine the relationship between autonomous motivation and hours spent training per week among student athletes who are actively competing in sports. Moving to the next slide. This is our research hypothesis. So, first null hypothesis HO, there is not significant relationship between autonomous motivation and hours spent training per week among student athletes who are actively competing in sports. Second is alternative hypothesis HA. There is a significant relationship between autonomous motivation and hours spent training per week among student athletes who are actively competing in sports. Moving to the next slide. So next is data management from Excel to SPSS. So you save this file Excel, then name that file you want to name like SPSS, then you click save. After that, moving on to SPSS. First you click file, import data, CSV data, then you insert your file access. Yeah, yes, then click SPSS, then open. After that is the data from Excel that we put for participants. So this is the data from the Excel. we have 35 participants in this Excel. So next is data. So next for manual scoring, intrinsic regulation. So first thing first, you should open the bracket, then you click number 3 minus number 9 and minus number 17 and then you divide by 3, and then after that you click OK, and then the data is going out. Yeah. Moving on to the next slide. Next, for manual scoring integrated regulation, first you type integrated, okay, and then you clear the data before, okay, and then you open the bracket, then you click number 4, insert, minus, and you click number 11 and minus, and you click number 14, then you divide by 3, then you click OK, then the data is out. So for the identify regulation, you do the same thing. You type the identify, and then you open bracket, you click number 6, then you insert and you minus, and then you click number 12, then you minus, then you click number 18, then you divide by 3, then you click OK, then the data is go out. Yeah. Okay, for the introjected regulation, you can do the same thing. First thing first, you open bracket, then you click number 1, then you minus, then you click number 7, then you minus, and you click number 16, and then you divide by 3, you click OK, and then the data is going out there. For the manual scoring external regulation, do the same thing also. You type external, and then okay, you open the bracket, and then you click number 5, and then minus, then you click number 8, and you minus, and you click number 15 and divide by 3, then you click OK, then that is the result. For the non-regulation, also you do the same thing. You open bracket, you click number 2, and then you minus number 10, and then you minus number 13, and you can divide by 3. Okay. And then after that, the result is going out there. For the non-regulation, also you do the same thing. You open bracket, you click number 2, and then you might. Okay, so for the autonomous motivation level, intrinsic, integrated, and identify regulation, you do the same thing. you click transform and compute variable, and then you type auto momentous motivation, and then open bracket, you click number 3 and minus, and then you click number 9 and minus, and you click number 17 and minus, and you click number 4 minus, you click number 11 and minus, you click number 14 minus, and you click number 6 minus, click number 18 and divide by 9, then you click OK, and the result there. Okay, next for descriptive statistic, demographic data. First thing first, you should click analyze, and then you click descriptive, and then you click age, gender, type of sport, state of the sport, and hour spent training time. Then you click mean, medium, mode, standard deviation, median, and maximum, and then you click OK, and that's the result. The statistic, the frequency table of age, the age and the gender, the type of sport, state that sport that evolve, and the hours spent training per week. Next is hours spent training per week. So you click analyze, descriptive statistic, and then you click hours spent training, and you click statistic, then you click mean, median, mode, standard deviation, median, and maximum. Then you click OK. That's the result for the hour spent training per week. So next is intrinsic regulation. So you should click analyze, and then descriptive statistic, and you click frequency, and then reset first, and we find intrinsic. Okay, you click, and then you click statistic, and then you click a mean, median, mode, standard deviation, minimum, and maximum. Then you click OK. That is the result for the intrinsic regulation for descriptive statistic. So for the integrated regulation, we do the same thing. You click analyze, descriptive statistic, and then frequency, and then you click integrated, you click statistic, you click mean, median, mode, standard deviation, median, maximum, and that is the integrated for descriptive statistic. We're moving on to the next slide. So next is introjected regulation. We still do the same thing. You click analyze, descriptive statistic, frequency, and then you click introjected and click statistic, then mean, median, mode, standard deviation, median, and maximum. Then you click OK. So the result is out for the introjected regulation for descriptive statistic. So next is introjected regulation. We still do the same thing. You click analyze, descriptive statistic, frequency, and then you click introjected and click statistic, then mean, median, mode, standard deviation, median, and maximum. Then you click OK. So the result is out for the introjected regulation for descriptive statistic. Next is the external regulation. Do the same thing. You click analyze, reactive statistic, frequency, and then you click external, then statistic, then you click mean, median, mode, standard deviation, mean, and maximum, and then the result is out for the external regulation. For the non-regulation also, we do the same thing. We click analyze, reactive statistic, frequency, and then you click non-regulation, click statistic, median, mode, mean, standard deviation, minimum and maximum. Then you click OK. Then the result is out for the non-regulation. We're moving on to the next slide. For the non-regulation also, we do the same thing. We click analyze. So next is autonomous motivation level. We still do the same thing. We click analyze, reactive statistic, frequency, and you click autonomous motivation level. Statistic, mean, median, mode, standard deviation, minimum and maximum, and then you click OK, and then the result is out there. Autonomous motivation level. So next is inferential statistic for generate HO and HA. So for the null hypothesis, there is no significant relationship between autonomous motivation and hour spent training per week among student athletes. For the alternative hypothesis, HA, there is a significant relationship between autonomous motivation and hours spent training per week among student athletes. So next is set the significant level. The commonly used significant level is A equal to 0.05. Decision rules: if P below than 0.05, reject HO. And then if P more than 0.05 is fail to reject HO. Moving on to the next slide. Okay, this is the inferential statistic that check the assumption. So assumption 1 is continuous variable. Both variable should be continuous. Autonomous motivation is continuous. Questionnaire score for our training is continuous. Next. So this is how we do the assumption 2 test of normality. First you click analyze and reactive statistic, explore, and then you click autonomous motivation and hour spent, and then you click plots and click stem and histogram, and you click bong So this is how we do the assumption 2 test of normality. First you click analyze and reactive statistic, explore, and then you click autonomous motivation and hour spent, and then you click plots and click stem and histogram, and you click next is assumption 3 for linearity. First is click graph, and then click view chart, and then select scatter or dot on gallery, and then choose simple scatter. Next, insert variable, and then auto minus motivation level on y-axis, hours training on x-axis. Proceed and click OK. The results show almost a straight line that conclude a good relationship between variable. So the assumption met. So next, we move on to test statistic and p-values. First thing first, you should click analyze, and then you click correlate, and then you click auto manage motivation and our spend training per week, and then you click option, and then you click mean and standard division, and then you click continue, and then you click person and details, and the result is out. So next, we move on to test statistic and p-values. First thing first, you should click analyze, and then you click correlate, and then you click auto manage motivation and our next is statistic decision. Since the p-values is 0.405, then greater than the significant level A equal to 0.05, the null hypothesis is not rejected or fail to reject HO. This indicated that there is not statistically significant relationship between auto-managed motivation and hours spent training per week among student athletes who are actively competing in sports. If the correlation coefficient R is positive, it may suggest to positive trend, but because the p-value is not significant, this relationship is not stronger enough to conclude that it's easy in this population. For the conclusion, a person correlation was conducted to examine the relationship between autonomous motivation and hours spent training per week among student athletes who are actively competing in sports. The analysis show that the relationship was not statistically significant, p equal to 405. Therefore, the null hypothesis was not rejected. The finding indicate that there is insufficient evidence to conclude the auto-managed motivation is significantly related to the number of hours sport training per week among the student athletes in these studies. That's all from our group. Thank you.